In this video, we're going to learn about and practice applying Newton's second law in calculations, relating force, mass, and acceleration. You have just thrown a ball, and it's travelling upwards, neglecting air resistance. What force or forces are acting on the ball? A. The upward force from your hand. B. The downward force of gravity. Or C. Both of these. The answer is just the downward force of gravity, which gradually slows the ball, stops it, then brings it back down, making it fall faster and faster. The unbalanced force here causes the ball to change its velocity. Now look at this ball thrown sideways, but with elastic attached. The force on the ball must be towards the hand, caused by the piece of elastic, which slows it down and then brings it back to the hand. This is just like the ball thrown upwards, except that it's the force from the piece of elastic that slows the ball and then brings it back. What else could happen to an object when subjected to an unbalanced force? When forces are unbalanced, objects can speed up, slow down, like the thrown ball, but also change direction. Think of trying to change your direction on a muddy football field. Normally, you dig your boot into the ground to provide the force to change your direction. But in the mud, you just carry on in the same direction, and you call it a skid. The larger the mass of an object, the larger is the force needed to change the direction or its speed. Think of trying to push a car compared with a bicycle. Also, the faster you want something to get moving, the bigger the force needed. Think of pedaling a bike. The harder you push, the quicker you get going. The relationship between force, mass, and acceleration is known as Newton's second law of motion. It can be summarized in this equation. Resultant force equals mass times acceleration. When force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second. A spacecraft with a mass of 7,150 kilograms accelerated away from the International Space Station towards its re-entry point with an acceleration of 2 meters per second relative to the International Space Station. Calculate the resultant force on the spacecraft. Pause the video and work it out. How about this example? A car of a mass of 1,200 kilograms starts moving and accelerates on a racetrack. The car's engine produces a constant force of 3,400 newtons. A constant frictional force of 400 newtons acts on the car. Calculate the acceleration of the car. Pause the video while you work it out. Now calculate the force required to make an 800-gram toy car accelerate at 8.2 meters per second. Take care with the units. And the mass of an object accelerating at 0.8 meters per second when a resultant force of 200 newtons acts upon it. So why do you think you can throw a tennis ball much faster than a shot put? Because the force from your arm is the same, but the mass of the shot is much bigger, so its acceleration will be smaller.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out our AddyESchool app as well? Until next time.